Welcome to the Explainer. So, if you've been keeping up with the Web3 space, you know that the Ethereum Name Service, or ENS, is pretty much the foundational identity layer for the decentralized internet. But right now, we're witnessing a massive fundamental shift on Ethereum L1 with the ENS v2 upgrade. We're talking about moving away from just a simple naming service and really evolving into a robust, programmable, on-chain organizational framework. It's a huge deal. Here's our roadmap for today. We're going to cover 1. The flat registry problem. 2. ENS v2, going hierarchical. 3. Instant subtree management. 4. Enhanced access control roles. And finally, 5. The future of on-chain identity. If that sounds like a lot of heavy smart contract architecture, do not worry. We're going to break this whole thing down into perfectly digestible pieces. Let's dive in.
Starting off with Part 1, the flat registry problem.
Okay, so to really understand the problem we're solving here, we first have to acknowledge the absolute success of ENS v1. It brilliantly replaced those complex hex addresses with human-readable names. But under the hood, it operated like a giant inflexible corporate phone book. One central flat registry contract enforced the exact same rules for every single name. It was elegant, sure, but super rigid. ENS v2 completely flips the script by introducing hierarchical registries. Think of it less like a phone book and more like a modern IT directory, where every single department just manages its own server. Every name can now define its own unique registry and its own resolver. Now, that old flat structure created a really specific bottleneck known as the zombie record. Because everything was mapped flatly, if a parent name expired, it actually didn't automatically clear out its subrecords. So you could literally have a parent domain lapse, but its subnames would just kind of float around actively in the registry. This created super confusing data remnants and, frankly, a pretty frustrating user experience.
To really feel the ultimate pain point of V1, imagine you're running a DAO or a big gaming guild. At the end of a season, you need to update or reset, say, 1,000 member subnames. In ENS v1, you had to modify each and every one of those individually. I mean, just imagine the tediousness of that. And even worse, imagine the astronomical gas fees of processing 1,000 separate transactions just to manage your own organization's namespace. It's a total nightmare.
Which brings us to Part 2, ENS v2, going hierarchical.
The core solution lies right here in this new architecture. A hierarchical registry is essentially a directed graph, which just means it flows top-down, kind of like a tree. The power over ownership, transfer rules, and resolution logic isn't forced through some single monolithic contract anymore. Instead, all that power is placed directly in the hands of the individual name owner. You dictate exactly how your specific namespace behaves. But wait, with all these independent custom registries floating around, how do applications actually find anything? Well, enter the universal resolver. It acts as an incredibly smart router in 3 elegant steps. Step 1, it starts at the root registry. Step 2, it drills down or recursively traverses to the deepest registry that actually has a resolver set. And step 3, it queries that resolver for the requested record. The beauty of this is that it handles all the complex routing completely behind the scenes. Client applications don't have to bear the heavy burden of figuring out these complicated pathways. And we definitely can't ignore the technical efficiency here. Every single registry implements a specialized standard called the ERC1155 singleton. Why does this matter? Well, it treats your subdomains as independent NFTs, but it actively skips all the heavy, expensive balance tracking that you normally see with tokens. By stripping out that unnecessary overhead, it essentially creates a gas-optimized container. It makes secure, hierarchical subdomain management surprisingly cheap. Moving on to Part 3, Instant Subtree Management. Remember our DAO manager from earlier, stressing over those 1,000 subnames? Well, here is their new reality. Because of the new hierarchical structure, the manager can simply deploy a single, fresh subregistry for the parent name. The result? That entire subtree of 1,000 names is instantly replaced or deleted in one single operation. It allows organizations to seamlessly issue and revoke identities at massive scale without breaking the bank on gas. And tying this back to our earlier zombie record problem, look at how this tree structure naturally prunes dead branches. Under ENS v2, immediate expiration is baked right in. When a parent name expires, it vanishes from the registry immediately, and the entire subtree becomes totally inaccessible right along with it. If it gets registered again, the new owner starts with a completely clean slate. So the zombies are officially gone.
Let's hit Part 4, Enhanced access control roles.
Back in ENS v1, if you wanted advanced permissions, you actually had to wrap your name and use a system of fuses. You were literally burning permissions permanently to lock them in. It was clever for sure, but really rigid. ENS v2 completely overhauls this by introducing Enhanced Access Control, or EAC. This is a highly flexible, gas-efficient, role-based system. It uses resource-scoped permissions to give you incredibly granular security, all without that permanent lock-in.
The shift here is honestly night and day. We're moving away from this clunky system of rigid fuses that apply globally to an entire name to a highly granular, role-based system where permissions are actually resource-scoped. Developers and organizations desperately needed this precise level of flexibility so they could build complex, real-world applications on top of ENS. And the sheer scope of this upgrade is captured perfectly by one number, 32. The new EAC system introduces 32 distinct resource-scoped roles. We are not just talking about a basic admin and user setup here. This is a massive spectrum of specific permissions that you can tailor exactly to your organization's unique needs. Let's break down exactly where these 32 roles can be applied. You get granular control at 3 distinct levels. First, you can set permissions at the resolver level, which affects everything inside it. Second, you can set them at the name level, scoping access to all records under a specific subdomain. Or third, and this is absolutely incredible, you can set permissions all the way down at the record level. That means you can restrict access to just a single social media link or one specific text file. And crucially, every single base role has a paired admin role to make sure nobody makes unauthorized changes.
So what does this actually look like in practice? Think about delegated content management. Say you have a primary domain, and you want a third-party marketing app to automatically update specific text records, like a social link or a bio. With EAC, you can grant that app the precise role to update only that specific text record without handing over ownership of your entire domain. It is an absolute game changer for multi-brand management and off-chain data integrations.
Finally, Part 5, the future of on-chain identity.
Before we wrap, let's address the elephant in the room for current users, backwards compatibility. The good news is, the upgrade preserves the past beautifully. All legacy names automatically receive an ENS v1 fallback resolver. The universal resolver handles the entire transition completely transparently on-chain. That means your existing setup won't break, and you literally don't have to take any immediate action until you are completely ready to upgrade.
The overarching philosophy of this massive upgrade is best summarized by a quote from the ENS team themselves. The goal isn't simply to help users manage individual names, it's to make naming infrastructure more useful for the increasingly complex ecosystems being built on-chain. That really hits the nail on the head. ENS is officially evolving from a simple nickname service into a highly resilient programmable organizational framework.
Which leaves us with one final thought. With hierarchical registries completely solving the flat registry problem, the absolute magic of instant subtree management, and the incredible granular security of those 32 EAC roles, the tools are finally here. So the question is your organization ready to build its entire internal structure as a programmable on-chain graph? Thanks for joining me for this explainer, and I'll catch you on the next one.